So now I'm going to be continuing on with a couple more things about definite integrals and some specific properties that you will want to know and be able to use. Okay. The first one is the integral of f of x dx from some a value to itself. What do you think that is? The area under the curve from A to A. Zero. It would have no base width. If you ever see the same number here as you do here, you know that the area will be 0. This does take one assumption into account. Assuming f is defined at a. That just means that the function has to exist at that a value. I mean, I'm not going to try and trick you with that at all, alright? But if you ever see a problem where it says, hey, find the area under the curve from 6 to 6, that would be 0. There is no area. It has no base. Okay? That's first property. Second property, if they ask you for the area under the curve, instead of from A to B, they ask you from B to A. Or it's actually backwards. Doing that will actually give you the opposite value of doing it from A to B, doing the integral from A to B. It kind of has something to do a little bit the direction you're moving. Okay? You know how finding the area under the curve, I first showed you using Riemann sums. We found the area of that first rectangle, the next one, the next one, the next one, and the next one. We moved from left to right. Okay? And we got a positive answer because each small change in x was a positive change. We were moving in the positive x direction, so we were getting a positive value for the area. Where if you go the other way around, you'd be moving in the negative x direction, so that little change in x is going to be a negative change. So it would give you a negative answer by doing this. Okay? It doesn't really truly represent what you think of as a concrete area then. Okay? So if they would tell you that the antiderivative or the integral from 10 to 4 of some function was negative 52, well then you know that the actual area under the curve from 4 to 10 is actually then a positive 52. Okay, so this is just to help you understand that always try to go left to right, small to big, but if they ever ask you for big to small, understand your answer you get will just be the opposite of what it would have been had you done small to big. Okay? Alright. Next one. Kind of takes this picture into account here. Definite integrals can be split up into smaller chunks. So if it would make more sense, if you had to find the area under this curve from A to B, which I know you wouldn't split this one up, okay? But if you wanted to find the area under the curve from A to B, could do two separate areas. You could find the definite integral from A to C and add that to the definite integral from C to B. So in other words, if you want to find an entire area, if it's easier to break it up into smaller chunks and find each chunk area individually, you could do that. So this is kind of our third property right there. I could find this area first, add it to this area, and that would give me the area of the whole thing.
Would that make it more accurate? Just the same?
No, yeah. You know, potentially that might be beneficial, especially if you had kind of like a piecewise function or something, and there was some sort of discontinuity going on maybe. Or maybe not discontinuity, because we actually can't do that. But if the function changed, in a sense, from one function to another one. We got that one. Another one. If you have some constant out in front of a function, just like with derivatives, you could bring that value out to the front and only work with the function itself. Just multiply it back at the end. All that does is kind of simplify it, makes it a little bit easier to work with, maybe makes it some smaller numbers that are easier to work with. If you have to find the definite integral from A to B of two functions added or subtracted together, you can do each one separately. So you could find the definite integral from A to B of f of x, and add that to the definite integral from A to B of g of x.
Why isn't there a dx in the first part?
Questions? Okay. And another one, again, probably should be kind of some common sense a little bit, but you will get a positive value or 0 or above you'll get an answer that's greater than or equal to 0 as long as f is integrable, meaning you can do the integral, and f is non-negative on the closed interval AB. So as long as the function is above the x-axis, you'll always get a positive value. those are the properties I want to go over right now. The practice problems that go with these properties are on page 279. (33 to 43 odd), 47 and 48. I'm going to do number 40 here for an example. You can follow along on page 279. Here's the given information. This information is given to us. So our job is to find the area from 2 to 4, to find the definite integral from 2 to 4 of this function, 10 plus 4x minus 3x cubed dx, given this information right here. So we don't actually have to graph it. We can just use this information right here. So if I want to find the definite integral from 2 to 4 of these three terms, can I work with them all individually? Yeah, that was one of the properties I showed you, right? F of x plus or minus g of x1. So I can split this up into the integral from 2 to 4 of 10 dx plus the integral from 2 to 4 of 4x dx minus the integral from 2 to 4 3x cubed. Okay. So, how am I going to find the definite integral from 2 to 4 of 10 dx given this information?
Could you pull out all the constants?
I can pull out all the constants, so I can move the 10 out in front here, the 4 out in front here, and the 3 out in front here. Because that was one of the properties, right? If I go back, this property here, if I have some constant, I can bring that out to the front and just work with what's left. So by doing that, I'd have 10 times the integral from 2 to 4 of dx plus 4 times the definite integral from 2 to 4 of x dx minus 3 times the integral from 2 to 4 of x cubed dx. Some of you probably aren't gonna have to write out all these steps, you can see where we're headed with this. Don't we know what the integral from 2 to 4 of dx is equal to?
2.
It was given to us, right? It's 2. So 10 times 2 plus 4 times
6.
6 minus 3 times
60.
60.
So it's a big weird.
Okay. So 20 plus 24 minus 180. Because I'm getting a negative answer, I'm guessing this function must dip below the x-axis. Remember I talked about the value will always be positive if the function's above the x-axis, but there must be a good chunk of this function that's below the x-axis. Okay? So 44 minus 180 is a negative 136. Okay? So we just kind of use some of these special properties to solve this problem. Okay? That's all that this part really will be about, is just kind of using those properties. I think the rest of it you should be able to handle. You'll be able to do a lot of it, probably even mentally a little bit. But it's going to be problems similar to this. Alright? So, page 279, 33 to 43 odd, 47 and 48.